All right, ladies and gentlemen, we're going to be doing the graphing of cube root functions. And just like before, we're going to do it using transformations. So let's just get started. Here is the generic shape of a cube root function. Cube root functions have an equation that have a radical 3, just like I have here. And it has an original reference point. There's 3 of them that are -1, 1, or -1, -1, 0, 0, 1, 1. I'll plot those for you. So it's 0, 0, -1, -1, and 1, 1. So it's very similar to a cubic function, but now instead of going vertical, so we used to go vertical like this. The inverse of the cubic function was the cube root function is a sideways cubic. Okay? And for the most part, the domain and range will be from -infinity to positive infinity, and the range the same as well. Okay, so again, you're going to be asked to memorize these points, which you should have memorized already. The only difference is when we graph a cube root function, understand the graph is going sideways and not vertical like it used to. All right, let's move on. So if you look here, again, these are the rules for transformations. I'm not going to necessarily read them again, but we still have vertical stretch, vertical compression, reflection over the x-axis. That's what the A controls. How do I apply the A? You multiply your A value with your Y values, okay? You will find the A value on the outside of the radical 3. The A value will be multiplying here, okay? Your B value controls horizontal stretch compression, and it also controls reflection across the y-axis, so left and right reflection. How do I use my B? Your B can be found by taking the number inside the radical that multiplies with the x, but don't forget, we got to take its reciprocal to get the true B. Okay, it's a common mistake. Make sure you take the reciprocal of this number, and that's your B. Your H will be inside the radical or in parentheses. You always want to switch the sign of the H. And once you have your true H, it shifts left and right, which means translates left and right. Your K is outside the radical, and that will translate up and down. Okay? Again, add or subtract the H for the X values, add or subtract the K from the Y values. All right, let's do some examples. Okay, first thing we want to do here is we are going to go ahead and, just like we did before, we're going to identify my A, B, H, and K. So A, B, H, K. My A value is -2. My B value, which would be the reciprocal of the number here, which is 1. The reciprocal of 1 is still 1. My H value is going to be this number, but switch sign, so it's +3. And my K value is going to be +2. All right, so how does the A value affect my graph? What does it do? Since it's positive, or since it's 2, we have a vertical stretch. Okay, and we also, because the A value is negative, we have a reflection over the x-axis. So a vertical reflection. Again, we really don't have to worry about this stuff when we graph because the process of graphing takes care of this already. Nothing's happening, no transformations for the B value. My H value is +3. So we have a translation. Remember, translation means shift. It's just a fancy way of saying shift. Translation to the right 3 times. And then we have a positive K, a +2. This is a translation or shift up twice. Okay? So now, how do I graph it? We got to remember these rules that I've listed for you here. 2, 3, 4, and 5. Okay, start with our original points. Our original points in no particular order. There's 3 of them now. And we are going to take our A values, and our A value multiplies with our Y values. So we're going to multiply all these numbers by -2, and then our B value multiplies with our X values. So 1. So do the multiplication. If you do the multiplication correctly, we should still have 0, 0 here. This turns into 1, -2. And this turns into -1, +2. Okay, now we're going to use our H and K value at the same time. The H adds or subtracts with the X's. The K adds or subtracts with the Y's. So we're going to add 3 to the X's and then add 2 to the Y's. So now we're going to have our final point of 3, 2. This will be 4, 0. And this will be 2, 4. And now we're going to plot these points. So 3, 2 will be here. 4, 0. Here, and then 2, 4 would be here. And again, we want to remember our original shape, and our original shape is a sideways cubic. Okay, and also keep in mind we have a reflection over the x-axis. So our original shape would have looked something like this, which I'm going to do in very light green. Our original shape would have been like this. So this is I would have been our original, but think about it. We flipped this over, so the bottom became the top became the bottom, and we did a stretch. So what our new shape would look like would be just the flip of that vertically. So it looks like this. Okay, and this is, the red is my final graph. All right, let's go ahead and do example B. Let's do the same process. Our A, B, H. Okay, so my A value in this case is going to be 1/2. My B value will be 1. It's a reciprocal of this number inside. My H value is going to be -2. Flip the sign. And my K value will be -1. Alright, so let's write what happens. This is going to give me a vertical compression. So we are shrinking our graph vertically. And we do not have a vertical flip or a flip over the x-axis because there's a positive here. Nothing's happening with the B value because it's equal to 1. Our H value, we have a translation, which just means shift, and is going to be to the left. And then the K value is a translation down. Of 1. Alright, now let's graph this thing starting with our original points. 0, 0, 1, 1, -1, -1. Our A value multiplies with our Y's. So we're going to multiply by 1/2 here. Our B value multiplies with our X's. Okay, if we multiply correctly, we get 0, 0, 1 comma 1/2, and negative 1 comma negative 1/2. All right, now let's do our H and K. So our H adds or subtracts to our X values. So we're going to subtract 2 here, or add a negative 2, however you want to look at that. And then our K is going to add or subtract with our Y values. So negative 1 here. So if we do the math correctly, we should get our final points. So we have negative 2, negative 1, negative 1, and this should be negative 1/2 if you do the math correctly, or negative 0.5 if you like decimals better. And this will be negative 3. Let me give you some room here. So this one will be negative 3, comma, negative 1 and 1/2. Okay, these will be my final points, so let's plot them. Negative 2, negative 1, negative 1, negative 1/2, so negative 1, and then negative 1/2 is here. And then we'll go negative 3, negative 1.5. So negative 3, negative 1.5. We'll go here. So again, these 3 dots look like you can connect them like a straight line, but we have to remember our radical shape, our cube root shape, which looks like this. Okay, and that would be our final graph. Domain and range wise, the domain is how wide do we go for this guy. So our red graph goes from negative infinity to positive infinity. Our range is how tall my graph is, so how low does it go? It goes to negative infinity, positive infinity. And then over here, the domain here, how wide is it? It goes from negative infinity to positive infinity, because it keeps going. And then our range, it goes how low? Negative infinity to positive infinity. All right.